Welcome to this explainer. Today, we're kicking off a heavyweight engineering showdown in offshore drilling. It's trade-offs part 1, space, cost, and filters. We're pitting single drive against multi-drive systems. So to really grasp why this choice is such a big deal, we gotta start with the blunt stakes of offshore engineering. Rig space is, quite literally, one of the most expensive real estate categories on Earth. Think about it. When you're sitting out in the middle of the ocean, every square meter is fiercely competing for its right to exist. Your electrical rooms? They're fighting for the exact same footprint as mud pumps, storage tanks, and crew quarters. You absolutely cannot afford bloated system designs out there. That brings us to round 1, footprint and switchgear. So just how much floor space and raw steel does each of these topologies actually demand? Well, with a single drive system, you have completely independent frequency converters. Basically, each one packs its own diode and inverter unit, meaning each drive needs its very own dedicated supply. But on the flip side, the multi-drive setup takes a totally different approach. It uses one shared supply unit that feeds a common DC bus. All the individual inverters just tap directly into that single shared line. Let's see how this actually plays out in a single drive schematic. Picture your 690-volt switchgear. For every single motor you're running, whether that's a drawworks, a top drive, maybe a mud pump, the single drive layout demands a full rated supply breaker and a dedicated rectifier section. So if you've got 10 drives, well, you're going to have 10 separate feeder breakers lined right up. As you can imagine, that completely eats up your available switchgear space. Now contrast that directly with a multi-drive setup. The difference right at the supply level is night and day. It only needs one main supply breaker and a common rectifier sized for the entire group of motors. Power flows right into that shared DC bus, and from there, it's just lighter feeder connections branching off to each inverter. The absolutely crucial point here is the multiplier effect. Single drive literally multiplies your switchgear, your cabling, and your floor space by the exact number of drives you're running. Multi-drive, though, consolidates all that power supply into just one main breaker for the whole group. Moving right along to round 2, weight and cost savings. Because offshore space translates directly to mass, and mass inevitably translates to dollars, this difference is huge. By totally eliminating redundant rectifiers and heavy-duty breakers, multi-drive compounds into some massive weight and copper savings. And remember, on a rig, every single ton messes with your stability calculations. So less steel, less copper and redundant feeders, and way lower switchgear costs? Yeah, multi-drive is the undisputed winner in this category, for sure. Which leads us to round 3, electrical cleanliness and harmonics. You see, physical space isn't our only constraint out there. We also have to actively manage the electrical environment. Rectifiers inherently draw current in pulses, and that creates harmonic distortion. In a single drive system, every independent rectifier is drawing its own distorted current straight from the switchboard. That makes bulky harmonic filters mandatory on practically every single unit. But multi-drive? It centralizes all that distortion at one common rectifier. You filter it once at the source, and boom, it's effectively handed for every single inverter downstream on that shared bus. So, quick check to make sure we're tracking this flow. Based on how power is drawn, which topology forces you to place a harmonic filter on every individual drive unit? Yep, it's the single drive. Because every unit has its own isolated rectifier pulling straight from the main switchboard, you are forced to mitigate that distortion unit by unit. That means buying, wiring, and installing a mandatory harmonic filter for every single drive. And of course, that adds back more weight and gobbles up even more of that precious, precious real estate. So, looking at our mini summary scoreboard for this explainer, multi-drive systematically beats single drive across the board here. It wins on space by sharing components. It wins on weight and cost by drastically reducing steel and copper. And it easily wins on electrical cleanliness with centralized harmonic filtering. But hold on, here is the pivot. What sharing a bus actually costs you. If you're an engineer watching this, you're probably sitting there wondering, okay, why would anyone ever spec a single drive system if multi-drive is this good? Well, there is a massive operational catch. Multi-drive looks like the clear winner so far, but sharing a bus means sharing risk. If that one shared rectifier trips, every single motor downstream goes dark simultaneously. In a single drive setup, losing one unit only ever takes out one motor. So I'll leave you with this thought. When you are hovering out there, lifting a multi-ton drill string, just how much redundancy are you actually willing to sacrifice for a smaller footprint? It's a tough call. We'll dive deep into fault isolation in part 2. Thanks for joining me on this explainer, and I'll catch you in the next one.